So increasing functions, lefts are going to be under, rights are going to be over. So it's always going to be that way. And so even if you have a function that is partly increasing, partly decreasing, some of the lefts will be under, some of the lefts will be over. But overall, if you have an approximation and the left is an under approximation, the right automatically will be an over. I mean, they're always opposite of each other, okay? But if you have a section of a graph or a graph entirely that is entirely increasing or entirely decreasing, and the term is monotonic. So if you have, I think we had that term earlier this year, but monotonic means one direction, basically. And so that means always increasing or always decreasing. So then, for sure, you would know the case lefts, and so decreasing left would be over and right be under. And then we talked about concavity yesterday. So here's kind of a picture to reinforce what we talked about with midpoint. So trapezoids, remember, connect from the left edge of the subinterval to the right edge of the subinterval and in a somewhat straight line. And so that's going to be under, it's going to curve over top. And then midpoints, we can think of midpoints now as that pivoted trapezoid, right? So yeah, it's a midpoint rectangle, which you could draw here, right? That would be actually the midpoint rectangle right there. But pivot that top, it's the same area. And so that's going to be an over approximation, and likewise over here. So just these little pictures can kind of be good to tuck away visually when you want to. Probably what I do is when I'm trying to remember concave up, I usually just remember the trapezoid one. And I say, okay, yeah, concave up, trapezoid would be over, so midpoint's got to be under, but whatever it takes to remember that. Okay, then we had these ways of writing them out, which is kind of what you'll see me do most of the time on these now. And then we had kind of our shortcut formulas, which you can use. And just remember on this one, it says 2n here, but it's only n back here. So if you have an S8, that's 8 subdivisions. But remember why that's, the reason that's an S8, it uses M4 and T4 is when you go here, your trapezoid, your four subdivisions for your trapezoid will use those there, but then the midpoint will use those. The midpoints will be those. Now all of a sudden you've got 8 subdivisions, right? when you do your Simpson. So the four trapezoid subdivisions, and then when you throw in the midpoint points with it as well, then all of a sudden you've doubled the number of subdivisions you have, and so that's kind of why that ends up being that way in that formula. So when you do an S8, we want to think of that as 8 subdivisions, okay? And so you should have 9 items. I don't know if I made a big deal about that yesterday. I kind of did towards the end, but if you're doing an L4, there would be 4 items here. If you're doing an R4, there would be 4 items here. If you're doing an M4, there would be 4 items in here. Okay, if you're ever wondering if you're doing enough of them or which ones do you have, now if you draw your x-axis thing like this, you're probably going to be fine. But when you do a trapezoid, if you're doing a T4, there's going to be 5 items in it. Okay, and if you're doing an S8, like we were saying here, there'd be 9 items inside of here. Okay, all right. And then we talked about amount of error, where this stands for the amount of error. Now, what I didn't put up, I don't know if any of your homework, I don't think any of your homework got into this. So this is probably getting into what we're going to talk about next week. Because we're going to talk about how does the calculator know if it's doing an approximation of a problem that there is no antiderivative. If we don't know the exact area, how in the world can we get how much it's off, right? I mean, the way you get how much is off is you take the exact area minus your approximation, and that's how much it's off. So how do we know how much it's off if we don't know the exact area? Well, we don't really know how much it's off, but what we'll learn about is we can figure out the max error. What's the most it can be off? And if we figure out the most it could be off, the worst case scenario, then we can figure out how accurate we are, right? So what's really happening is a calculator's doesn't say that they know that it's a 12-digit place accuracy. They know it's at least a 12-digit place accuracy, right? It might be even more accurate than that. But we can guarantee it's at least this much, and we do that because of what we'll call the max error. Okay, so that's getting into stuff a little later. Okay, and those are that's going to be from the library. Okay, so let's take a look at the homework. I do want to talk through some of those just to make sure we're understanding. Is there any questions on 1, 2, 3, 14, those were really the ones where you had to write out stuff. Anything on those? You want to check? Matter of fact, let's do this. Let's those. Okay, so let's see what. Okay, so for number 1, I've got like the exact answer is 2, and then 2.284. For the L3, the R3 is 1.784. The T3 is 2.034, and then the M3 is 1.983. Those are the decimals I got, or they got here. C then is where you're supposed to subtract those values, and then D, the approximation error then for the S6 was really small, like 0.00047, or those numbers sound right. Okay, number 2, now they've got them as fractions here, so maybe you had those other ones that way also, but this one, they got the exact answer. Number 2 is 1/4, and then 9/64 for L4, R4 was 25/64, D4 was 17/64, and then M4, they have 31/128. And then when you subtract those, you get those differences. And then the S8 was, says the error was 0 on that one. And then 3, okay, explain, you didn't really have to write that one out, but, so what'd you say on 3? You have the integral from 0 to 1, explain why. Basically they're saying L is under and R is over. Because did you graph it? I mean, basically they want you to graph it. If you have 0 to 1, sine of x squared, and it says explain why L4, was it L4 or L7? Why is L7 less than or equal to I, less than or equal to R4? Because this graph is what?
Always
increasing. I mean, that's the idea. So what you would want to do is you would want to graph that between 0 and 1. It's increasing. Why is an L, and it doesn't, they were trying to throw you off by making it 1, 7, 1, 4. It doesn't matter. It doesn't matter if you have 100 left rectangles. If the graph's increasing, 1,000 left rectangles is going to be an under approximation. Doesn't matter. So if it's always increasing, L is going to be under, R is going to be over. That's just what they're saying. So just some notational kind of stuff here. Okay? All right. So let's go to 15 through 18 then. It says give an example of a function where this will be true. So when they say L n is greater than I, what are they saying there? That the lefts are a overestimate, over approximation, right? So what would be a graph? And it doesn't matter, you could just describe it, or you could give an example. It says graphical or symbolic, right? So what do you want if it's L's are going to be over? Decreasing. So if you just, I'm fine if you just say decreasing. If you give, I guess we did have a quiz one time where I said give an example of the function, so maybe you should graph it, you know. There you go. Something decreasing, right? Part of a parabola, something, anything that's decreasing. You want to give it an equation form, you know, you can do that too. Okay, so rights to be under. 16, what do you got? Same thing. Trapezoids under. Trapezoids less than. Concave down. You just need something concave down. And midpoints over. Also concave down. Okay, so on 26, so let's look at the picture on 26. It says to rank, so they give you F, rank these in order. So basically they give you a graph that looks like this. Okay, so rank them in increasing order. So your first one should be the one that's the least, which would be what? The most under? What's going to be the most under? A left. That's going to be the most under. Okay, so L30. Then what's going to be the next most under? A trapezoid, because it moves. A trapezoid is going to be under, but not as much. So L30 is going to be the least. T30 is going to be more than that, but it's going to still be under. Then what? The actual answer. Then what will be over? Your midpoint, your pivoted midpoint, and then finally your right. Okay, so just a lot of different ways of talking about over, under. Pretty simple, really, I hope. Okay, 29 through 34. Okay, same kind of thing. They tell you that F is positive and increasing, so that just means it's above the x-axis and it's always going up. Okay, on this interval. So might be true, must be true, can't be true. So left is less than the interval. What do you got? Must be true. 30, midpoint is less than. Might be true, right? Because it depends on concavity. Here the midpoint, remember the pivoted trapezoid, here the concavity would be over, or excuse me, here the midpoint, the pivoted one would be over, here it would be under, right? Depends on the concavity, so it might be. Left is less than right. Must, okay, because lefts are all under, rights are all over. Left is less than midpoint. Must, right? Because lefts are going to be way under, right? It's just like what we were just talking about. Because it's increasing, lefts will be under, and midpoint we don't even know. Midpoint might not even be midpoint might not even be under. It might be over. So lefts are the most under, so they're going to be the smallest for sure. Okay, lefts less than trapezoids. What do you have there? Must be true. Again, lefts are less, the most under. And then trapezoids less than midpoints. Might be true. Same thing with midpoints, right? Here a trapezoid would be under, right? The midpoint here, a trapezoid would be over. Okay, so that would be a might be true. Okay, so that was kind of the big emphasis there. All right, so for today, we're just gonna let you have some work time on this project that's due next week for the Niobrara thing. So we were talking about this a little bit yesterday. Let me pull that thing out again. This was an example of somebody's, I think it was last year. I think that was Jesse Costas. But anyway, so what we, I mean, this is just a picture, some pictures of one of the groups. I was telling you, we just had a wooden rod there that was marked in 10-centimeter increments. We just went across the river, and you just barely see this string. You just barely see this string right here. And that was just marked with a magic marker at 1 meter increments. And we just went across, and we just went down and read, about where it was, kind of estimating, it's about halfway between 10 and 20, so 15 centimeters, so we were just kind of estimating that. So you're going to have, 2 pieces of paper to do your graphs, your long graph, and then 1 piece of paper for your stream. Again, the key is that you're going to go too wide. So if you've got your blue lines here, they're getting better. Okay, you've got your blue lines here, so you'd want to. Now this was a year that the stream wasn't quite as wide where we went across. I mean, the data I gave them last year went out to 144 meters, so they had like 72 rectangles. So you guys get up easy. My last year, I'm getting soft. So you guys only do like 58 rectangles. So there you go. But again, the key thing to understand is everybody, no matter whether you have the rights or you got the midpoints or you got the lefts, everybody's plotting all the points, right? So on your graph paper, give yourself room. Like I said, yours to go to 116, you're going to need about a page and a half, so you can trim it or whatever if you want to when you put it all together. But so here's your blue lines on your graph paper. And so at 0, whatever that is, and here's this one, and here's another one up here, and then maybe here, and then So you're gonna be plotting halfway in between. And then I want you to connect that with kind of a smooth, kind of don't connect it with, try to make it, kind of a smooth curve, not just, straight lines in between, and so you end up with this graph. So everybody would end up with that same graph and, of all the points, right? And then if you're a right rectangle person, then you would come in and you would have, that shape. If you're a left rectangle person, you would come in and you would have that part shape. And if you're a midpoint person, you're going to come in right here at the middle point and you're going to shape that, right? So everybody's will be 2 meters wide. Now remember, you do have different units here. So when you get your area, this is centimeters, remember, and this is meters. So you're going to have to adjust one of them, right? You're either going to have to take this one and move the decimal back 2, or take these numbers, make these 200, 400, 600 if you want to do that, right? Because those would be, so you get your units to agree. So you either should come up with an area that's centimeters squared or an area that's meters squared, right? So you want to adjust one or the other, and you can do that at the end too. And then on your stream, now the stream you don't have to worry about it, because on the stream then, on the stream, it's in 20 centimeter, I think, or you'll go 20, 40. Now that one, you've got more leeway. You could, you've got plenty of room on a piece of graph paper to do that. So you've actually got, I think there's 8 or 9 points to plot, so, like so, and you'll plot your thing. But go ahead and make 20 be the width. So if you're doing rights, doing midpoints, whatever. Okay, so go ahead and let those be. But this is centimeters here and centimeters here, so you're okay with those. Okay, but it's okay just to do 4 subdivisions on the string, 21. Okay. So really, that's all I got. I got extra graph paper if you want. So at least today, if you want to work on that, you can also work on the sample 3 packet. That's more of a long-term kind of thing. It's up to you, but you can at least get some of the busy work done and get the points plotted in. Yeah, let's do it. What? Yeah. Yeah. Yeah.
I'm gonna leave this on your desk here.
Yeah. Yeah, here's some rulers. Yeah. Got some of this and
And we drive down the beach, there's a guy going down the middle of the beach. You're down here.
There's a guy.
yeah, let's see, I got the packets, you can just put those tabular data packets you can put up here.
I have some sample packets for the second midterm, and I don't know if you looked at your answer there.
I did. Okay. Yeah.
Sorry.
Okay.
Yeah, did you have something to make up that you want to make up still? Or is it gonna be there?
I'm gonna get a discussion with this.
Okay.
I'll do that.
That's why you don't take classes that they test you.
You should see my schedule.
Where do we turn in these bags?
No, from everything, all the classes I picked out, I mean, doozy? It's a good doozy.
Here's some tape too, if you guys need it.
And then,
Yeah, they're just in this,
Okay, Harish, you ready to roll?
And shuck it or no?
Calculate.
here, matter of fact, just have me use mine.
I think. So we gotta learn from their mistakes. When they started, they had ranked number 2. They had ranked the centimeter outside. Actually,
no, I'd probably read this.
Really?
It's not a mistake, James, it's a plan.
Yeah. I just
Plan strategy.
It's hidden genius.
Yes.
Is it okay if I go talk to Robbie?
Thank you. Word. Mr. Clark,
Yeah.
you hear about Coach Carson?